So we're looking at section 11.2 for college algebra, dealing with arithmetic sequences. Think back to what we worked on the last couple days. We just had kind of generic sequences of numbers. You created lists, right? You generated the list of maybe the first 5 terms, that kind of thing. We're moving into specifically arithmetic ones. And then in section 3, we'll look just at geometric ones. But keep in mind, by the time we get to the test on this, you'll have just some random ones from section 1, and you'll have arithmetic and geometric ones. So you kind of have to be able to distinguish which ones are which. Okay. So topics today, we're going to be able to find the common difference for an arithmetic sequence, write the terms of an arithmetic sequence, and then create that general formula that would give us any term in our sequence. And then tomorrow we'll tackle the ones where we actually add them all up. All right, so first thing to know about arithmetic ones, they have to have what we call a common difference. That's what makes them arithmetic. They have a common difference. That means we're either adding or subtracting the same amount from one term to the next. I would suggest you highlight this. That's how you calculate the common difference. You take any term and subtract the previous one. So you could take the second term minus the first term. You could take the 10th term minus the 9th term. All right. And then we have 2 different versions. We have an explicit version and we have a recursive one. Now those terms were used in section 1. Explicit is nice if we are just looking for a specific term in our list. Maybe we want the 100th term. If we have an explicit rule, we can dump 100 into that formula and we get our answer. If we are dealing with a recursive formula, we have to create all the numbers in front of the one we're trying to find. So if I asked you for the 100th term and it was a recursive formula, you'd have to generate the 99 that come before it. Okay, we wouldn't want to do that. Recursive is fine if you're wanting to just generate the first few terms of a list, of a sequence, but it's not as useful if we want to find one further out in the sequence. All right, you'll notice some similarities in the 2. Both of them involve a first term. Both of them have this D, this common difference. In the recursive one, it says we will be given a first term. There will be a number here, okay? You have to have a starting point. Then it's going to tell us how do we generate the next term based on the previous one, okay? So if I want the nth term, I'm going to take the previous one and add my common difference to it. Okay? For an explicit rule, the formula says take the first term and add that common difference, but you're only going to add it n-1 times. Now here's why. Let's say we had a starting number of 3 and our common difference is a 2. Okay, means we're going to add 2 each time. So my next number would be a 5, and then I'd have 7 and 9, etc. Okay, think about the position. This is my first term. This is my second term, my third term, my fourth term. So if I want to go from the first term to the fourth term, how many common differences did I need to add? I added 1 here, a second one here, a third one here. So to get to the fourth term, I really only needed 3 of those common differences because I was already at the first position. Okay, I only needed to move 3 more spaces to get to the fourth one. So that's why it's always off by 1 here. Whatever you want, say you want the 10th term, you really only need to add 9 common differences. All right. I'm going to pause the video here and pass out a formula sheet. It's just kind of a blank chart for you to fill in. I want you to fill in the ones we've had so far. By the end of the chapter, before our test, you need to know them. Okay, so I would strongly encourage you to start studying them each night instead of waiting till the night before the test and having all these different formulas to try to figure out. Our first example says find the nth term of an arithmetic sequence whose common difference is 7 and whose first term is 12. And then they want us to generate the first 5 terms and find the 75th term. So are we given enough to create the nth term, that formula, the general rule for the nth term? Nick says, oh yeah. We have the information. Okay. A sub n equals what? Just give me the general formula. You wrote it down a minute ago. A sub n equals A sub 1. Okay. Now, a lot of people forget to put the plus sign in here. It's important that it's there. You're not taking A sub 1 times that other stuff. You're adding it to it. Okay? Now, let's plug in what we know. Our first term is 12, so we're going to have a 12 here. We do not know n. We're trying to come up with a generic rule for the nth term, not a specific term. But we do know our common difference is 7. Okay? And I am going to expect that you simplify that. So you're going to need to distribute that 7 and then combine like terms. It does not matter to me if you write 5 plus 7n or 7n plus 5. Those are equivalent. Okay. I want you to put a box around that because we're going to come back to that in a minute. So we now have this formula that says 5 plus 7n will give me the nth term. So can I generate the first 5 terms? All I have to do is plug the numbers 1 through 5 into my formula. So first term is going to be 5 plus 7 times 1. Second term would be 5 plus 7 times 2, etc. All right, so simplifying. What do we get for our first term? 12. And that's a good check if we did the formula right, because they told us our first term was 12. Second term would be 19, then, okay, good. All right, now look at your list of numbers. How much are they going up by? And was that the common difference? It's supposed to go up by 7? Okay, to find the 75th term, we simply want to plug 75 in for n. All right, so we have 5 plus 7 times 75, which gives us what? Nick's going to count on his fingers. The rest of you could use a calculator if you want. He's going to get back to us in an hour with the answer. What do we get? $530? Okay. All right, second example says find the nth term of the sequence -6, -2, 2, 6, 10, etc., and then find the 15th term. So this time they're giving just a list of numbers instead of telling you all the information about it. But from that list, can you identify the first term? Okay. So the -6 would be my a sub 1. Can you identify the common difference? Remember that formula we had at the very beginning? D equals a sub n minus a sub n minus 1, a term minus the previous one. All right, well, let's just take the first 2 terms. -2 minus the previous term of -6 gives us what? So if you look at your list of numbers, does it seem like we're adding 4 each time? Okay, that's our common difference. So we have a first term and we have a d value. That's all we need to plug into our formula. I want you guys to get in the habit of writing this rule or formula down The more times you write it, the easier it's going to be to remember it. So let's plug in our numbers now. Our first term was -6, and our common difference was 4. Go ahead and simplify that. All right, so you should have -6 plus 4n minus 4. Combining like terms, a sub n equals -10 plus 4n. Is that what you got? Okay, go ahead and put a box around that because we are going to come back to that in a minute too. Now this time they didn't ask us to generate the first few terms. They just said, can you figure out the 15th? So a sub 15 would be -10 plus 4 times 15. What do we get? Okay. All right, so the two formulas that I had you put a box around, I want you to compare the formulas. What do you notice about them? Do they look similar? Do they look similar to something you used to graph? They kind of look like that y equals mx plus b. Different letters, but the same idea. So when you're dealing with arithmetic sequences, it would be a linear picture. If you graphed each point in the sequence based on its position in the sequence, you would get them all the dots lining up in a straight line. Okay? So that is one way to tell if a formula represents an arithmetic sequence, if it looks linear. Okay? The other thing I want you to look at, in the first one, we had a 7 times n. What did the 7 represent in that question? It was the common difference. Looking at the second one that we put a box around, we have a 4 times n, and in that one 4 was the common difference. So when we get this all simplified down, we have a d term times an n term. Does that make sense? Okay, now look at the other piece. In this first one, it's a 5. In the second one, it's a -10. Where would those numbers be in my list if I were to generate that list, that whole sequence? Where would we find those numbers? Yeah. If we went back one space here, we're adding 4 to move to the right, so if we subtract 4, we can back up one space, and we'd be at -10, which is what we had here. In this first example, we started with a 12, and our common difference was 7. So if we backed up, subtracted 7, we would have been at a 5. And that's what we're seeing here. Okay? So remember when we talked about if we're starting with this first term to get to the fourth, we only need 3 common differences? Well, if we back up one space and we start with what we call the 0th term, then I would need 4 moves to get to the 4th term. Does that make sense? So that's an alternate formula. You can go ahead and add that to your yellow sheet. I'm okay with whichever one you choose to use. This would be an explicit one again. But it's basically saying we can work backwards and find that 0th term. And then we need exactly n of our common differences. Okay, so that should go in your explicit one. Explicit arithmetic. Okay. Question 3. What kind of formula are they giving us in question 3? Lauren said recursive. Yes? How do we know it's a recursive one? It tells you the first term. Okay, that's one of the clues. What else? We said it tells us the first term, and they have to. If it's recursive, they have to tell you where it starts. But look at your formula for the nth term. What is this? That's your previous term. A recursive formula is always going to reference that previous term. Okay, we're doing something to the previous number to get our next one. So we do have a recursive formula here. What is it that we're doing to the previous number? We're adding 5. So what would that be in our sequence notation, our language of sequences? If you're going to add 5 to the previous number to generate your list. What is that? I start with the number, I add 5, and then I add 5 again, I add 5 again. It's my difference, my common difference. So they told us the first term, they gave us a formula to show us the common difference without actually saying, here's your common difference. Okay, so this plus 5 here is our D value. So once again, we know a first term and we know a common difference. Can we write the rule for the nth term? A sub n equals, everybody? Everybody? A sub 1, come on guys. A sub 1 plus what? Okay. Again, the more you write that, the more you say that. Right now, you've only got a couple options, but by the time we get to the end of this section, or the end of this unit, you're going to have a lot of formulas. You've got to start saying them and writing them. So what do we know? First term is 6. And our common difference we said was 5? All right, simplifying. What do we end up with? 5n plus 1 or 1 plus 5n? Either way? Okay. Now, does that fit that rule we just looked at? Is 1 my 0th term? Okay. So I could have said, you know, this is a sub 0 plus n times d. Right? It fits that pattern. Okay. Find the 100th term. So we just want to plug 100 in. Hopefully we don't need a calculator for that one. I know you don't have enough fingers, Nick, but you can get there. Okay. All right. Question 4. Find the first 6 terms of the arithmetic sequence. If the 4th term is 20 and the 13th term is 65. Now, they've given you a little bit of a challenge here because in the past, we had to know an a sub 1 and a d, right? We aren't given either one of those. But we are given 2 numbers in our sequence and we're told what positions they have. And from that, we can work backwards. We can find our first term, we can find our common difference to write our equation. A couple things I want you to pay attention to. In that formula, a sub n equals a sub 1 plus n minus 1 times d. Look at your subscripts. This one said we are going to start with the first term, right? And we want to get to an nth term. And the number of common differences we needed was n minus 1, right? Just this one minus this one. So if I wrote a sub 6 equals a sub 4 plus some common differences, how many would I need? How many jumps is it between the 4th term and the 6th term? 2. And I would get that by taking 6 minus 4. This one minus this one. So I don't have to start with the first term. I can start with any term. I just have to either know the common difference or know another term in my sequence to figure it out. All right, so what we are basically told right here, a sub 4 equals 20. And right here, a sub 13 equals 65. So they've given me a little snapshot of 2 places in my sequence. Start with the smaller one and build up to the bigger one. Okay, so I'm going to start a sub 4. I'm going to add some common differences until I get up to a sub 13. So using that same pattern, how many common differences do I need to get from the 4th term to the 13th term? How many do I need? 9. And I can plug that in as just a 13 minus 4. So instead of n minus 1, I can use the 2 values I'm given. Okay? So plugging in what we know, our 13th term was 65. Our 4th term was 20. And we said we had to add 9 common differences. So from this, can we figure out what that common difference value is? If we subtract 20, we have 45 equals 9d, so d has to be 5. Okay. Now I can work back from that and figure out what my first term is. Using this same analogy right here, if I want my first term and I know my 4th term, how many common differences do I need to add in? I need 3. I'm going to write it as 4 minus 1 so you can continue to see that pattern. So it's always this subscript minus that subscript. Okay? So let's fill in what we know. Our 4th term was 20. And our common difference we just found to be 5. So if we add 3 of those 5s, what's my first term going to be? Okay. So I know my first term, I know my common difference. Can I write my rule? Yes. All right, let's go ahead and do that. What would be my 0th term? It'd be 0. Why? We're starting with a 5 and we're going to add 5 to move to the right. So I have to subtract 5 to move back. So what's my simplified version for a sub n? My 0th term is 0 plus n times d. So 5n. All right. So from that, can we generate the first 6 terms? All right. So 5 times 1, 5 times 2, etc. So we end up with 5, 10, 15, 20, 25, and 30. Now, we were told the 4th term was 20. Did it work out that way? Was our 4th term 20? Okay. Our 43rd term would be 5 times 43. Good. All right, the last one that we're going to look at today says find the nth term of an arithmetic sequence where our common difference is 4 and the 6th term is 94. I'm going to pause the video. I want you guys at your tables to talk about this one. Think about what's your basic formula? What pieces in that formula do we already know? Okay, so we were just talking about knowing that common difference is 4 and the sixth term is 94. That means if we put an n value of 6 into our formula, we should get an answer of 94, right? That's what they're telling us. So if we go back to that formula, a sub n equals first term plus n minus 1 times d, well, we can put a 4 in for d. We know that. We don't know the first term, but we do know a different term. We know the sixth term is 94. So if we put a 94 in for our answer, what was the n value that we were using? The n value is 6, so we'd have a 6 minus 1 here, simplified down to a 5. All right, so we get 5 times 4. We've got 94 equals a sub 1 plus 20. So our first term has to be 74. Yes? Okay, so we want a rule for the nth term. A sub n equals first term plus n minus 1 times d. Plug in what we know. First term we just found out is 74. We were told our common difference is a 4. What am I going to get when I simplify that down? Now, does that fit with that other pattern we had of the 0 term plus n times d? Would 70 be our 0th term? Yes? And we have d times our n? Okay. First 5 terms. Putting a 1 in there, we have 70 plus 4 times 1, or 74, which we already knew. Putting a 2 in, we get 78. Putting a 3 in. Okay. Putting a 4 in. And putting 5 in. So are the numbers going up by 4s? Which was what the common difference was supposed to be. All right, so for homework tonight, you're going to work on page 1036, questions 2 through 34 even, and then 59 to 64. You have about 15 minutes now to get started on this. Make sure that you're studying that yellow chart each night so it's not a panic the night before the test.